And our next speakers are Elisabeth Sedano and Christopher Hayden from University of Southern California.
All right, thanks so much to everyone for having us. We're happy to be here. My name is Elisabeth Sedano. I'm an assistant professor with the Spatial Sciences Institute at USC.
And I'm Chris Hayner. I'm a student of Dr. Sedano. I'm also an urban planner in New York. I'm a practicing urban planner.
So our project is creating a police violence risk map. We see it as a counter map to modern policing methodologies. So our background is the domain of predictive policing. More and more these days, law enforcement agencies are using algorithms to help them plan where and when they are going to patrol. The issue with this, and there's a number of issues, but one of the issues is that when they are trying to predict where their patrolmen should go, they are using past data. And past data often means past crime data. And past crime data incorporates within it any of the biases in policing that led to the creation of that data. And so crime data is not a record of all crimes committed. It is a record of criminal actions that particular police departments have decided to enforce. And it's not, therefore, a complete picture. And as we've seen in a number of cases, law enforcement has discriminatory processes to the detriment of Black and brown communities.
So just as a little bit of a motivation for why we are undertaking this police violence risk map, it largely stemmed from the summer of 2020, where we saw the tragic death of George Floyd and many other folks at the hands of police officers. And it really sparked a cultural zeitgeist where we were talking about policing, we were talking about other things as well, longstanding institutional racism that contributed to disparate access to opportunity, unequal exposure to risk, and disparate attainment of generational wealth. Our motivation is just to further this as geographers. We want to be part of this discussion. We want to be useful allies.
So our project is a counter map. The big question here is, what would happen if we took these methods that law enforcement agencies are using and sort of turned the tables and applied them to the behaviors of police departments, as opposed to on communities themselves? And counter maps, of course, can be created for a number of different reasons, such as highlighting data that isn't often highlighted, using innovative methods, using new data and methods to help communities that aren't the usual recipients of the benefits and the results of these types of technologies and data sets. And our visual here is the $1 Million Block project, which is a very interesting and insightful counter map. Do you want to say a quick word about it?
The kind of interesting and compelling thing about this project is they're trying to visualize the expenditure that we have spent as taxpayers on incarcerating folks, and how they are so spatially concentrated. So it makes you wonder, like, is really incarcerating people the best use of our tax dollars, or should we just feed it into communities? And would that be a better use of our money to not spend it on incarcerating people?
Yeah. And this really highlights sort of the power of maps. So that you can easily see, once you know what's being mapped, you can easily see the disparate, in this case, spending across urban space. So we are creating a counter map using what can be critiqued as flawed methodologies to sort of turn the tables, but also to see what we can learn. Okay, so our objective here is to expose the vulnerability of at-risk populations and sort of see what spatial factors, what environmental and other spatial indices might correlate with higher levels of police violence across city space.
So we're going to pilot our police violence risk map in New York City. One of the key reasons we're doing this is just the sheer availability of data. The New York Police Department has cataloged all of their crime data going back to 2006. So we just have a really rich repository of information at our fingertips. We have all the summons information, all the arrest information, and we also have stop and frisk information. Another reason that we're doing it is it has a really diverse, but also really segregated population. So it makes it a very interesting case study. And another reason that we're looking at it is it has some really high profile police violence cases, like Eric Garner, but also some really notorious policing programs. It was kind of the epicenter of broken windows policing. It also was the epicenter of stop and frisk policing in the Bloomberg administration. Just to give you a little bit of orientation, because I think it's going to be important when we get to our results maps. You're looking at, sort of the city here. In the center of the city is obviously Manhattan. This is where our CBDs are. It is the most dense borough of the city. It's also very white, south of 96th Street. Oh, great, awesome. So here is Manhattan, right here in the center of the city. The subways emanate outwards, and that's where population is also dense, and it largely follows the subway lines. North of Manhattan is the Bronx, and you can see that the colors here are indicating different races. So northern Manhattan and the South Bronx is heavily Black and Latino. And you can see that especially in the South Bronx, it's mixing. And as you go further north, it switches to largely Black. Going east of Manhattan, this is the borough of Queens. It's one of the most diverse counties in the country, if not the most diverse county in the country. But it also is very segregated. You have pockets of white folks in Western Queens. You have a Latino pocket in Corona, and then moving eastwards, you have a Black pocket in Hollis and St. Albans. In going down into Brooklyn, it's largely the same story. It's white west of Prospect Park, and then moving eastward, it becomes very Black when you get into Bedford-Stuyvesant, Brownsville, and East New York. Staten Island is sort of the odd person out here. It's largely suburban. It's very white, and then the only place where it becomes a little mixed is in northern Staten Island. And unsurprisingly, this is where the Eric Garner murder did occur.
Okay, so for our method, we decided to employ Maxent, which is a machine learning program designed for habitat suitability modeling. So you input points of presence of species, be it plant or animals, and you bring in a whole series of environmental layers, such as precipitation, elevation, air temperature, etc. And biologists and ecologists can use this to assess where different species might thrive. Okay. this methodology is being employed outside of the realm of ecology. And I've found a number of papers where people are actually using it to help model human processes, human spatial processes as well. And I especially like the idea of using Maxent for this issue because Maxent program is a presence-only model, which means that to the data for where species exist, you can just use like presence points. You don't need to use what are called absence points. So, which would be where like a field worker, a biologist will go out and say, no, this species of bird does not exist at this place. Okay. Absence data is often difficult to bring together, and it's difficult to be able to say that a species has never actually been at a particular place. So presence data is much more trustworthy. And for the for police violence, it's going to be difficult to be able to say specifically where police violence has or hasn't occurred. Very often, it's a type of thing that could be occurring all across an urban space. Okay, and so when Maxent, when the program is going through its machine learning process, it will randomly choose what's called a background point across your whole study area extent. And if a presence point is not at that location, instead of modeling it as an absence point, it models it as a maybe. And so I thought that type of sort of algorithmic thinking was very suited to this issue. So for our presence data, we are using the Fatal Encounters data set. This is a volunteer geographic information data set, so crowdsourced data of fatal police encounters across the US. As opposed to crime data, law enforcement agencies across the US have very little rules telling them that they have to keep track of police violence. And even when they do have to keep track of events, they don't have to often share that publicly. So whereas with crime sets, you can often find authoritative data sets, with police violence, you really can't. And so this is where the power of the mapping crowd has really stepped in and created this data set, which is far more comprehensive than any actual official data set. As noted, it only is fatal encounters, so that is one limitation there. But it is sort of the best that we have.
In terms of the inputs that will feed into the model to generate the prediction of where future fatalities might occur or where it's riskier, we've broken them down into 4 categories. So these are sort of these are to our model what precipitation or elevation might be to an ecological model. The first 2 we've already discussed a little bit. This is what typical policing models look at. They look at crime data or they look at environmental data. Crime data, we've chosen to look at summons data. So these are instances where a police has stopped someone and given them a violation. And in addition to that, we're looking at misdemeanor arrests. So these are low-level crimes. In terms of environmental data, what we've looked at largely are things like the land uses of our particular property. So, retail stores, vacant lots, liquor stores, proximity to transit, particularly transit entrances, bus shelters, things of that nature. Sensitive places in the city like highway overpasses that have come up in the literature as being places where crime may occur. And then also the land cover, the tree canopy and prevalence of grasses and shrubs in a particular area. In addition to these two major factors that go into a lot of predictive policing programs, we've also looked at the literature, and in particular, Devin Carbato has written extensively about this, and the importance of demographic data in influencing police behavior. For this particular category, we've looked at segregation data and also vulnerable populations. So in particular, homeless shelters for our model. We've also looked at police presence. The idea behind this is that the more likely a police officer is to engage with a particular person, the higher risk they are that violence will eventually occur over repeated interactions. So for that particular category, we're looking at stop and frisk data.
Yeah, I'll just add on to that quickly that yes, our Carbato in particular, this 2016 article, he puts forth factors that influence the disproportionate levels of violence by law enforcement in the U.S. against Black people. And so one of his main things is that wherever the police are going to be is where you're going to get more violence at their hands. And so, I mean, it sounds, common sense, but there it is. And as it turns out, as the data show us, that police tend to be more in the communities where there are more Black and brown people. So I feel like we are probably running short on time. So yeah. Okay, 5 more minutes. Okay, so I think we'll skip.
Yeah, that's fine.
Yeah. Detailing these, except we will just talk for a moment about stop and frisk.
So this is an interesting variable, and it's because it was so controversial in New York, it's maybe worth a little second to talk about. So New York, like many other cities, has a stop, question, and frisk policy. Other places call this a Terry stop, and oftentimes it becomes notorious in other places for vehicular stops made by the police. In New York, it's largely pedestrians. So we have our own kind of version of this. But the police department can stop someone if they have reasonable suspicion that they might have criminal activity. It's sort of a lighter probable cause of the Fourth Amendment. This program was expanded greatly during the Bloomberg administration, and you can see it spiking here in the sort of the mid 2000s and peaking around 2012, where hundreds of thousands of people were stopped annually. And you can also see that it's disproportionately Black and Latino folks that are being stopped by the police officers. It became very controversial, and also the administration changed, and you can just see how rapidly it dropped. So this becomes an interesting data input that we wanted to test and see what that did to our model.
Okay, so our early results. So this is what our sort of early results map looked like. You'll note with the legend here, since we're all cartographers here, we'll talk about the symbology. I chose this stretch color scheme here, and I decided to remove the numbers. Okay, so we're not trying here with this effort. We're not trying to actually quantify and give like accurate numbers of risk across city space here. Okay, our point is to show the variability across city space. And so we can do that just with the our color ramp here. So we see that the spatial characteristics that correlate with white victims of police violence are pretty dispersed across the city. Now, this really varies with the spatial pattern of Black victims. So again, the spatial characteristics, and so this is not we're not quantifying risk. We're not saying that Black people in this part of town versus this part of town definitely are suffering at a higher level of risk. What we're saying is the environmental variables that correlate with instances of police violence are to be found in these locations. Okay, and so those environmental variables really are concentrated for the Black victims of police violence. So here they are side by side, so you can see So the concentration is really occurring in the neighborhoods that Chris highlighted that has higher populations of Black and brown people.
Just to layer onto that a little bit, there's also besides of those neighborhoods, there's a couple moments where you see just sort of a pop of an outlier. For example, right here in Long Island City, right here in Red Hook, and right here, these are interesting outliers, and it happens that there are New York City Housing Authority public housing in these locations, and then this is the Port Authority bus terminal. So that kind of interesting things that might influence further thinking about our models. In the white map, it's also interesting that there is risk associated with white neighborhoods, but there's also moments where you can start to see an underlying spatial pattern that for instance, you start to see linear moments that are kind of have the rhythm of a subway stop. You can see that also in Staten Island here. This is a local commuter line.
So the most important variables for each model, be them the Black victims of police violence versus white victims of police violence, by far the most important variables were stop and frisk. So where police are to be found, which of course is also related to where police are actually summoning people and arresting people. But stop and frisk is really like where they've put themselves on patrol. So strongest variables. And so we have mapped the stop and frisk count. So we already heard that the stop and frisk numbers were huge and disproportionate towards Black people. But with these maps, we can see that the disproportionality of stop and frisk is also spatial. So we're using here the same symbology here, the same cutoffs on each map. And you can see that the stop and frisks of white persons are nowhere near the numbers, nor as spatially dense ever as against Black people. And this is really true in these particular Black communities. So we decided to remove the stop and frisk layer just to see what we could learn about the secondary variables. And we found that the same spatial patterns did hold true. Okay? So with Black victims, we found, again, the concentration, and with white victims, the environmental variables, again, were distributed. However, the nature of these important variables were different in each of the maps.
It's interesting that in the Black violence map, a lot of the key variables tended to be crime related, and you can see their spatial concentration. So it's no surprise that they're resulting in the same concentration of prediction. They've also rely upon one of our segregation indices, Black isolation, to predict that, as well as an environmental factor, the density of grass, and that's an inverse correlation there. For the white violence map, it's much more dispersed and distributed, and it's much more reliant upon environmental factors. So you can see, the liquor stores, the vacant parcels, they're kind of randomly distributed across the cityscape, payphones as well. Interestingly, it also is relied upon Black isolation as well in its prediction.
Yeah. So, concluding thoughts. So, yes, we feel that we can model spatial variables that correlate with police violence. And we found that the patterns of those spatial patterns of those correlations vary by the race of the victims. We found that police activity was more of a strong variable with Black victims of police violence, whereas environmental variables were more informative towards the map of violence against white victims. So in our next steps will be to further tune the models and to study the models spatiotemporally, especially given the importance of stop and frisk as a factor, but the way that stop and frisk has changed in New York over time. That's all. Thanks so much.
Thank you.
This is a really fascinating talk. I wish we had time for more, but maybe we can sneak in one question. Any questions for speakers? And maybe this would be a good time to also acknowledge our online participants. And we do have a student helper here who is monitoring the chat. So if you have any questions, put them in the chat, or you can raise your hand and we can answer questions online as well. Any questions? Yeah.
Yeah, thank you for your presentation. Very insightful. I'm interested. Have you had a peer review of this, and kind of what was the feedback that you've gotten on that? Maybe
This is our first airing to a group of our peers, so we were excited and nervous. Yeah, and we look forward to feedback.
Okay. We have one question from online. Can we allow an online speaker?
Hello,
Oh.
can you hear?
Hi, yes.
Hi, thanks. So I did hear in the beginning of the presentation that that one of you is a student of the other. Is that as I understood? But I also wondered, yeah, okay, thanks. I wondered if you weren't involved as a student, how do you think that collaboration between academia and city planners might have happened? And might you, when you publish on this, also sort of speak to how those collaboration pathways could be made? Because I think they're really crucial for us to do this kind of really important work moving forward. Thanks so much for your work.
I can try,
Yeah.
I mean, I completely agree with you, and that's, sort of my kind of mantra of wanting to kind of keep pursuing education and learn, not only to kind of feed my own interest, but to make connections and learn from, my professors and make, insightful cross-pollinations across sectors and disciplines. I try to foster that in my workplace and have, several colleagues that are, inspired to try to do something similar. And I definitely think that that's a great model that others should pursue. I think cross-disciplinary collaboration is fantastic.
Okay, well, thank you both again for the wonderful, stimulating presentation.